Oh, hello.
Hello,
Can you hear
good
me?
evening. Yes,
Nice, nice. Thank you for your time in joining this. My name is Alex, and I've been working for one of a big tech company more than 5 years, and also working as an interviewer for system design and algorithm question for the current company. So for your this session, I'll run the interview, like real interview for you and your practice. How does it sound?
yeah, sure. That sounds great.
Okay. Before we start, why don't you give me your background a little bit, like your back-end design experience, etc., so I can kind of adjust expectation for this session for us.
Okay. Uh, yeah. So basically, I'm a backend software developer. I work in one of news companies,
Mm-hmm.
basically online news. So we do news recommendations, and I have worked on distributed systems
Mm-hmm.
at the back end of that particular team. And I worked on content ingestion, modeling, and ranking of the news articles for particular users, and
Mm-hmm.
we recommend news articles across the world.
Mm-hmm.
So, uh, and I've also designed a couple of projects, and one of my recent projects was picked up for a talk in our company's internal conference.
Mm-hmm.
So that is my design experience. And when it comes to system design interview, I barely have any experience. I would say complete noob.
Mm-hmm.
And this is just my second system design mock interview. I'm just trying to get a feel for it as I'm preparing.
Okay, sounds good. All right. Okay. Let me copy and paste the my question here. Before that, as you know, system design is usually open-ended interview. There's no like absolute answer or wrong answer, as you know. It's just kind
Mhm.
of open-ended. So basically, we are supposed to discuss and share our idea. And as an interviewer, I want to check your technical background, experience, the backing of your suggestion on the system design.
So,
Yep, this is question. You might have seen this before, but let's not care about that. Again, it can go in many, many different ways based on your suggestion and our idea. Take your time and let's start when you're ready.
okay, so basically, they're asking me to design a certain version of WhatsApp. So,
Mm-hmm.
okay, let me ask a couple of questions. So, looking like you're asking me to design a group chat. So, do we not have? Oh, we have one-on-one messaging as okay. And do you want me to cover notification?
Notification on client. Yes, it should be.
Um, are we just covering images or are we also covering videos?
Just the image and file is fine, I think.
Do you want me to cover things like encryption and security and so on?
It's good for you to mention this, but let's not cover that for now.
So basically, a basic WhatsApp messaging can be in plain text, and it can go from this confirmation to
Mm-hmm.
message. Okay. So I can also assume this is similar to Facebook Messenger, right?
Yeah.
Okay. So okay. Hmm. Okay. So maybe I can ask this. I'll need this data while estimating. So I can mention my assumptions. Please correct me if I'm wrong.
Mm-hmm.
So something like number of users,
Mm-hmm.
right? Something that can be what? Something like let's say WhatsApp has like a billion users, so we can say 1 billion daily active users.
Oh, let's say just 1 million daily active user for your assumption. Yeah.
And I'll assume that we are doing image compression, and
Mm-hmm.
every image will be like what? 0.5 MB,
Yeah, up to maybe 1 megabyte. That's fine, I think.
and every message will be probably 100 bytes.
What do you think? What should be like max length of the each messaging for users?
I think 100 bytes is reasonable on an average.
Okay,
Okay. So I'll give you topics which we can cover. In a 1 hour, usually we cannot cover everything. So I'll tell you what are the different topics I can cover, and let me know which ones you want me to emphasize on. And I can
sure.
tell you what I feel are important. Okay. So basically, obviously, you have mentioned requirements, but I can go deep into it, and I have to get into non-functional requirements and so on. And in my opinion, it is important. That's why I'm putting a star as a suffix. And we need some estimates. I think it's important. And we need some API design. I can mention it verbally and need not dwell too much into it. It's up to you. And database schema, in my opinion, is important.
Mm-hmm.
And we need component design, and then we have approach or algorithm. So this is where we the hash, or how do we actually create IDs and so on. uh, I can again touch upon it or go deep into it. It's up to you. And then we have data application, partition, and caching.
Mm-hmm.
So when I say caching, this will include load balancing as well. Usually they go hand in hand. Then I can talk about telemetry and permissions. So if you tell me which ones are important for you, then I'll just keep focusing more on that as I go on explain.
Sounds good. I think we can focus on the component design, obviously, and
Mhm.
also the data replication plus API design. That would be our main discussion topics, I think.
Cool. So you have mentioned the requirements.
Hmm.
Um, so I'll probably start with the non-functional requirements.
Sure.
Uh, so this is slightly, I would say the system has to be available, not available. Um, Definitely needs to be consistent to some extent because the messages should not be lost.
Hmm.
And I think availability can slightly take a hit. Uh, yeah, so the messages should not be lost,
Hmm.
and it has to be available. Um,
Hold on a second. Can you define what's the difference between available and consistent or reliable? How is it different?
okay, so basically, reliability is more of making sure that the data does not get lost,
Hmm.
making sure that the data is there at any cost, and even though it is delivered late. Consistency is more like acid or atomic properties, where you try to make sure that every version of the group message is same as soon as you can.
Hmm.
uh, Something like that. And the availability is the server being available and accepting the messages and acknowledgements quickly, uh,
Hmm.
and taking the responsibility of the message transfer on its own. And yeah, partition tolerance is the system uh, being able to handle the load even if one of the partitions went down, and not
Hmm.
losing any major chunk of data or process in meanwhile.
Okay.
So that's why I'm choosing reliability. That is, you make sure the data is there.
Hmm.
We have to be as consistent as we can,
Hmm.
as much as we can. But even though there is a delay of few seconds, it is understandable.
Hmm.
And we definitely need it to be partition tolerant. That goes with reliability, and preferably low latency as much as we
Sure.
can, and it should happen with real time. So I would say these are important non-functional requirements. If it's okay, I can start with estimates.
Hmm.
Okay. Um, So, okay, we said 1 million daily active users. So, estimates involve four kinds of things. We have traffic, we have storage, we have bandwidth, and we have memory, right? So, let's calculate traffic.
Mm-hmm.
So, we have 1 million per day. That would end up at, so I'm just opening calculator to get it properly. Seconds per hour. Probably I would say approximately 12 messages per second, and we can approximately say uh, you can assume a user would send 40 okay 12 users per second. So every user might send 40 messages per day, and every message can be approximately what 500. I'll take it as 500 bytes, right?
Mm-hmm.
I'm just trying to find a intermediate thing between photo and the message.
Mm-hmm.
So on a daily basis, we have, let's say, 1 million into 40 messages is involving 500 bytes. It would be somewhat like what was it, 20 million. And see, so it will be, I would say, 20 million kilobytes. That will be
Mm-hmm.
kilo uh, tera. I think it's somewhat like close to 20 terabytes per day. Is that correct? Sorry,
Yep.
mega.
Yep. Yeah, that's fine.
No, no, it's mega giga. Sorry, it's 20 gigabytes per day.
So 1 megabyte by multiplied by 40 and 520 gigabytes per day. Is it? Hmm.
Yeah.
Okay.
Sorry, and let's say we are assuming it's for we are storing it for 5 years. Let's say because we have to store older messages as much as we can.
Mm-hmm.
So this will come down to 20 into 365 into 5, 36.5 GB, which will be 36.5 GB. So not taking into account replication. I'll come to that later.
Sure.
Right? So now we have bandwidth. Bandwidth is more like yeah, that is, let's say, 20 GB of data per day. That will come down to say 20 GB. I'll call it as, let's say, 20,000 bytes divided by 24 divided by 1,100. So 0.23 MB per second. So 0.23 MB per second will be 230 kilobytes, kbps. Yeah. So memory, we can always assume 20% hot users were always very active, and we try to keep them in the cache. So 20 GB per day will translate to, let's say, 20% of it is 4 GB per day of caching. Right? So
Mm-hmm.
these are the rough estimates.
Is,
And
is the memory is about like a single host or the overall memory usage per day or per second?
now it's the overall memory usage per day.
I see.
We'll, we'll be distributing it. Yeah.
Okay.
Yeah, I know the numbers look small. That because our estimation of number of users is 1 million. That's why it looks small. Uh,
Mm-hmm.
so yeah,
Including
if you go,
files, images as well, right?
Huh?
including files and images as well.
Uh, 4 GB. So I'm assuming the compression here. I mentioned it.
Hmm.
So I assumed a certain amount of, because WhatsApp does that compression. If
Mm-hmm.
you see, your original photo is compressed and they store a very lightweight version of it. So I assumed that compression, and accordingly I had assumed it. So every message I said 500 bytes, and accordingly I went on design.
Okay. Okay. Sounds good to me.
Okay. Let's see API design. So these are the APIs we'll be calling the system with. So something like we can have not. So do you want? Okay, I had to clarify this in the requirements itself. Do you want the user active notification as part of this or not? User being active is online or offline. Do you want that notification, or if not, I can just skip that.
Let me just skip that part, I think, for now.
Okay, cool. So, and do you want the feature of deleting a message?
Yeah. Here.
Okay, you want the deleting the message, right?
Yep. Yep.
So we'll have then our post and probably delete API designs. So we'll have the API dev key, we'll have his user ID, and we'll have his new message coming along. Uh, we can call it as group ID and message coming along,
Mm-hmm.
or I can call it room ID as a generic thing, something like that. And then API deletion will also be something very similar. We'll have a dev key, we'll have a user ID, we'll have room ID, and we'll have message ID for deletion.
Why do we
And
need an API dev key? What is that for?
so API dev key is to uniquely identify the application,
Mm-hmm.
the particular client,
Mm-hmm.
and make sure that we don't get we see that our network is not abused
For
by
testing.
by DDoS or something.
Okay.
Uh, so yeah, after post we'll have we return act with the message ID,
Mm-hmm.
and later we can have a read notification that the other client has read, or how many people have read,
Mm-hmm.
something like that. So deletion is also, we can have we return the act. Okay, and okay, let's see database schema. So database schema is definitely important. So we can have a very simple MySQL database
Mm-hmm.
for user information. It need not be MySQL, it can be NoSQL also, because I don't think we are really doing much joins here. So we'll have user information and messages.
Actually, I have interested to discuss about that first, like MySQL versus NoSQL. Can you just give me like pros and cons of each solution for your design?
Sure. So MySQL is obviously consistent and it's a highly available
Mm-hmm.
database, and NoSQL is more like partition tolerant, and either you have to choose between availability and consistency. So that is the main thing, and the main uh, design decision you take based on how many tables you have, and how are you, if you're making joins.
Mm.
So if you're making joins, then definitely MySQL is the way to go. But if you're not making much joins, and let's say your data is not so structured, and let's say if you
Mm-hmm.
want to store data with variable sizes, and let's say every row has different number of columns and all kinds of different structures,
Mm-hmm.
then NoSQL is the way to go.
So do you mean like there's no SQL solution supporting join today?
Not as efficiently as MySQL.
Hmm. Interesting. Okay, what if we have to scale up our system since we are receiving huge traffic more and more? What would be the better solution between the two, you think?
For this application,
Yeah.
see, for storing the message itself, I definitely recommend NoSQL.
Mm-hmm.
Uh, but the user information, we can choose either one of them. I think because user information is static in the sense, uh, the fields are static, it's not changing. Like we'll
Mm-hmm.
have one user ID, we'll have one his creation when he logged in, creation date, and last login, and so on. So these are all things which are not changing. So we
Mm-hmm.
can keep it at MySQL level because it's
Mm-hmm.
structured and it's simple to understand.
Mm-hmm. Mm-hmm.
And messages themselves are dynamic and the sizes vary. And so we need to be able to write lot of small information and update it quickly. And such things can be very well done in HBase
Mm-hmm.
because it is a balance between consistency and partition tolerance. So yeah, it is modeled after Google's Big Table, and it runs on top of HDFS, Hadoop Distributed File System.
Mm-hmm.
So that's why for message itself, I think HBase is a good choice. It's very well designed for
Mm-hmm.
that. But user information itself is almost like a metadata.
Mm-hmm.
So it can be in MySQL or a small NoSQL like Cassandra or DynamoDB. It should not make much difference.
I see. So how many other tables are you thinking about the system rather than just user table?
So there is user info, and we need some level of message ID and metadata. I think message ID and synchronization information. That
Mm-hmm.
is one another thing, and then we need a follower, uh, or I can call it as member table. So I'm slightly torn between whether I should maintain the group chats independent of the individual chats.
Mm-hmm.
So I would say probably from the perspective of normalization, it makes sense
Mm-hmm.
to have that. So like group table, and we can have individual. Uh, again, I can call it as one-on-one one-on-one chats, something like that. So
Uh-huh.
basically, here, yeah. So here we maintain like I'll create a group ID,
Uh-huh.
and we'll have members, member IDs, and so on. For probably group table itself, I would recommend something like Cassandra because Cassandra is designed to have a key with unlimited number of columns, and it can change. And just because you're changing the number of columns in one row, it does not disrupt other rows.
Mm-hmm.
So everything is a container in Cassandra. So for group table itself, Cassandra is good. But for one-on-one chats, maybe simple MySQL is fine.
That's
Uh, be-
interesting, sir, because you are suggesting that we can adopt like a hybrid of the database per table, which is kind of some interesting idea to me. Is that what you're trying to say? Is it right? So for the group chat, you can use MySQL, and group table, you can use the Cassandra, and for other table, you are suggesting MySQL or NoSQL. Is it right?
yeah, I
Mm-hmm.
don't, because we're not doing any specific joins between each other. So
Mm-hmm.
I don't see any damage in doing this.
Interesting. Okay. Okay. Have you ever, do you have experience there operating a system consisting with of like multiple different database before? Just wondering.
Yes, at least in my team, we do use different databases for different storing
Mm.
different objects. Like for
Mm.
user profile, we have a separate key value store. For all news articles, we use our own abstraction over Cassandra.
Mm-hmm.
So that's how we store it there. And for all caching purposes, we use Redis. So
Mm.
I think it's fine. In fact, we parallelly call them.
Mm-hmm.
So I think it's fine. It's fine. I think it's done very common in industry today.
Okay, okay, fair enough. Let's continue, please.
Okay. So even one-on-one chats we can have. Here we just probably need to have maybe a simple room ID and member pair, something like that, right? Here we have to see if let's say particular one member ID has a chat with another member ID.
Mm-hmm.
We can call it probably member ID one and member ID two because there are only two of them. So so on, and message ID and synchronization info, right? So basically, uh, this is part of. Okay, so we need to have a separate synchronization service,
Mm-hmm.
and it can, I think, can be dealt separately that way. I'll come to that in probably data in component design. I'll come to synchronization service. It's very important.
Mm-hmm.
So in that, I think we'll need this. It's important. So I think at a high level, these should be enough. We need some user info. We need group information about the group chats, information about the one-on-one chats, and we definitely need one table for messaging.
Mm-hmm.
Okay. So I can probably start talking about component design.
Sure.
So components wise, probably how about I share a Google drawing? Is that okay?
Sounds good to
I'm
me.
not a Google drawing. I have draw.io, which is linked to my Google. I think this will reveal my identity, but I
Mm-hmm.
think it's okay.
Sure, this should be fine with me.
Okay, but yeah, here it is. Just see if it works for you. This is first time I'm using it. Uh,
I'm trying to access it. Let me see. Still loading. It takes some time, I think.
if it doesn't work, I can probably create a Google drawing and give that. That might be
Yeah, I think it's kind of stuck in. I don't know. Yeah. Let me just refresh the screen just in case. It's not working for me, sir.
okay. Give me one second. The application and
Yeah.
okay. Can I try the second link?
Sure. I think I'm in.
Cool. Yeah, I can see.
Cool.
Okay. So okay. In component design, I thought it will make sense if I just start drawing.
Mm-hmm.
Uh, so probably we can start with something like a client. Uh, have a client. So this client can be a mobile or even a desktop, so
Uh-huh.
on. Probably I'll come to nitty-gritties. It will only make a difference in the pagination. Other than that, not much.
Are
Uh,
you assuming that a single user have only one client or multiple devices at the same time?
they can have multiple devices. That's why we need synchronization service.
Perfect. Okay.
So then we'll do one thing. So then we'll need some application service. I'll call them as chat service. So there are certain details of chat service that I had to cover. Probably I'll mention them verbally. Is that okay?
Mm-hmm.
So chat service basically there are multiple ways we can push or pull the chat, right, or long poll, so on down. So one way is, you push like every time you have something, or like something like, let's say there is a client has to keep asking the server, keep asking, okay, do you have one, do you have one, something like that.
As a polling, okay.
So trying to pull something, so
Mm-hmm.
usually that causes unnecessary burden on the network. So I think a good option is probably something like a long polling, where
Uh-huh.
you ask the server if it has something, and then keep the connection open, and the server responds back if there is something, or if the something is about to time out, it will just send a ping and it will just keep the connection open.
So
So
both client and the server has to maintain the connection as open. Is that what you're trying to think so?
yeah,
Okay. Is that different from WebSocket? Just wondering.
uh, I think they're similar.
Hmm. Okay.
Long polling, I think it's slightly different, based on the same concept. I think WebSocket and long polling are slightly different. Need to read exactly how they are different.
So which protocol are you thinking between the client and the server? What protocol
Protocol,
has the long polling? Just wondering.
huh?
What protocol has the long polling feature? Just wondering.
Must be TCP/IP.
Okay. HTTP, you mean?
Yeah, it's HTTP. Yeah.
Okay. Okay. Is there any downside of like maintaining the connections between client and server? What if we have a tons of clients, like more than 1,000 at the same time? Would there be burden to server to maintain that connections as often? What do you think?
Definitely, the downside is the number of servers we have to maintain. So
Mm-hmm.
we'll have to, like, let's say the modern server, powerful server can maintain 50,000 concurrent connections.
Mm-hmm.
Then we just need to literally scale linearly to the number of clients we have.
Hmm.
So yeah,
So all the connections should be in memory, I guess, right?
yes,
Okay. So the server should have a huge physical memory, I guess.
correct. Yeah.
Is it like a scalable solution, you think? Just wondering. Or do
So
you suggest, can you suggest some better option if you can think of? Just wondering.
yes, we can definitely suggest, but it will come at the cost of consistency and
Mm-hmm.
latency.
Hmm.
So we can always use a messaging queue in
Mm-hmm.
between, something like a Kafka or something similar, which takes it, and then we can use a pub/sub model
Mm-hmm.
to deliver the messages uh, to the database, and that triggers a change log to return something to the client.
Mm-hmm.
So that is more efficient from the perspective of the number of servers, but at the same time, it comes at the cost of latency and
Hmm.
consistency. Yeah.
What's the latency that you expect? I mean delay.
Uh, with the
How slow is it? Just wondering. Yeah.
how much slower than keeping the connection open?
Yeah. In a rough
Uh,
estimation. Basically I just want to understand the why what's the kind of better option for us? And I want you to convince me of your design.
got it. So yeah, uh, yeah. As far as I have understood, I think what Facebook
Mm-hmm.
actually follows is what I initially mentioned, which is it actually keeps the concurrent connections open,
Mm-hmm.
and as long as the user is active, if the user goes offline and if he's not responsive for certain minutes, then it will just switch it off. So
Mm-hmm.
that's why they give a very engaging experience. As soon as you text, it's immediately there and they respond, so on.
Mm-hmm.
So if we take that away, that open connections away, then we'll get something called as a Gmail experience,
Mm-hmm.
where you send something, it reaches there. Definitely, memory-wise, it's more efficient, but it will not create an engaging experience because you have few seconds of delay or something like that.
Hmm.
So
Okay.
that's so so that is the key point. So it depends on the experience we want to give to the user.
Okay, I think that makes sense to me for now. Let's continue on your design.
Okay, so we need chat servers, and this will speak to a synchronization service, and the chat service will directly talk to a couple of databases. Like we can have, this is like the messaging database, and I'll just create for all other DBs. I'll just call it as metadata database, and we can have one more metadata here like this, and and obviously have, once we have this, uh, so we can always have a cache in front of it.
Mm-hmm.
So we can call it as read through cache, where something is not present, then we pick up from cache, or if something is present, we pick up from, if it is not present, we pick up from database and then write it to cache and then pick it up from. So, so the chat servers can directly talk to messages and metadata, but I would suggest having a separate, uh, two separate servers, like for data access. I can call it as block servers and the metadata servers.
Mm-hmm.
This is just to scale them individually, separately. Sometimes it makes sense. And let's say something, if we get servers which can handle photos more efficiently, then we can just easily replace them without
Mm-hmm.
disrupting the other ones. So, so let's say chat servers talk to block servers, chat servers talk to metadata service, they talk to synchronization service, and synchronization service has, uh, okay, sorry. So let's say the synchronization service also speaks back to chat service, and triggers if something, uh, so there are multiple clients, right? So if you see that our client sends a message in WhatsApp mobile,
Mm-hmm.
and sees that the chat service takes it and then finally saves it in the database, synchronization service reads it from, hears it from the metadata service, and then it tries to update all other
Mm.
similar clients. So block servers read from cache, and they can also read directly from uh, the database. Sorry, and can have a relationship like this.
I'm sorry. I'm kind of have lost you. Sorry. Can you just explain again, like roles of the block server and the metadata server in this diagram again?
So blocks, they're just data access objects.
Mm-hmm.
Uh, so basically, they just fetch the data for you and gives to the chat server whenever they ask for.
I see.
So I
Then
just kept them separate, just to give them opportunity to scale independently.
scale independently as a microservice, you mean?
Yes, yeah.
Huh. So is this arrow like flow or synchronous, or there's a asynchronous flow as well?
I would say they're asynchronous. Yeah.
Which part is asynchronous? Sorry, everything or
Uh, let's see. So I mentioned there will be concurrent connection between the client and the chat service,
sure?
and I would say everything else is almost asynchronous, because you write it, give it to block service write it to the database. So does the metadata service,
Mm-hmm.
and synchronization service probably has a long polling with the metadata. As soon as it sees that a new message has come in,
Mm-hmm.
then it triggers the synchronization service to make sure that everybody in that room is synchronized with that particular information.
Hmm.
So
Interesting. Why
yeah,
it has to be asynchronous? Just wondering.
Uh,
I mean, there's definitely pros and cons of being asynchronous and synchronous, right?
so,
What's the particular advantage of being asynchronous in this case, you think?
yeah, being asynchronous probably less uh, load on the servers
Less load on service. Hmm.
and not as many connections you need to open, less load on the bandwidth, uh, so on.
Mm-hmm.
So when it comes to client and the chat server relationship, it makes sense to be available most of the times, just to
Mm-hmm.
give a very real time feeling to the client that at least okay, we have received it. At least give that one tick, tell him
Mm-hmm.
that okay, we got it, we're sending it as soon as possible. But at the back end, we have a much more complex system, and
Mm-hmm.
there is usually a lot more than this is happening. There is a batch processing happening, there is a real time data processing happening, there is a
Mm-hmm.
notification system which works in parallel. So internally it completely makes sense to keep it asynchronous.
Hmm. Okay. Hmm. I
And
see. Oh,
as
go
as
ahead.
soon as so if we, let's say, hypothetically, if we have a synchronous system, right, we don't
Mm-hmm.
need this message database, we don't need this metadata database, you just get it, you send it, right? So the very fact that we have these databases is to say that uh, we need it to be stored for a while for it not to be lost in case the connection breaks.
Mm-hmm.
So there itself, when as soon as we bring a database or a queue or any storage in between, we are already choosing an asynchronous format.
I think even for most asynchronous service, you need a database to store the data and for debugging any purpose, in my opinion. I think in usually a system is asynchronous is because it has to be scalable with some time. Like we use a queue, message queue database as a queue. Some other solution like a server just can keep like store the messages in the queue, and we have a synchronous worker then pick it up asynchronously and handle it properly. So in such way, in front end server, it can receive the messaging no matter what traffic it is, right? That's a kind of one of the biggest advantage of the using asynchronous service, in my opinion. So I'm just trying to find the reason that why your system has to be asynchronous impartially.
Okay,
Yeah, I think yeah, your answer kind of makes sense to me partially. But time being, I think you can continue to finish the component, and we can just continue to discuss based on that. What do you think?
sure.
Sure. Let's continue. Yeah, I want to see your design more and more.
Okay, and obviously we need some load balancing. So let me mention that here.
Sure.
Definitely um, one here. We can have one here as well. Need one between client and server,
Okay.
so something like this. So we need one between the server and the databases. We need one between the client and the chat server.
Mm-hmm.
So load, as I'm writing this, I'll mention. So load balancing, the most rudimentary way is round robin. Definitely nobody will agree that that is the modern solution. Uh,
Mm-hmm.
eventually we need to have an intelligent system which probably takes into account, let's say, uh, well, we can have something like a least number of connections, or we can have something like a weighted least number of connections, or we can have something like least response time. So whichever server is giving least response time, give data to that. Or we can check the memory usage in each of the servers, and whichever has the least, okay, put more load on it. So
Mm-hmm.
we can have intelligent systems which is a combination of these conditions,
Okay.
and that can be a more efficient system. So
Yeah,
uh
I think we can skip the load balancing algorithm part because that's obvious. Yeah.
okay, fine. So
Mm-hmm.
basically after chat servers, so I have to put a pub sub model on next to it. Maybe I can make that change. So, so basically there will be a chat server and it will talk to a PubSub model.
Mm-hmm.
And then, uh, yeah, so basically the PubSub model will probably uh, make sure that the data is divided to different account to different destination and client. Uh, no, the PubSub model will probably, in a reliable fashion, send the messages to the
Mm-hmm.
destination servers.
Mm-hmm.
Let's say somebody is in USA, somebody is in India, and you're sending a message. So then the
Mm-hmm.
PubSub is supposed to keep track of which, so that will come in partitioning. So which user is connected to which server and send it to that server.
Mm-hmm.
So and so on. So probably I can talk a little bit about data partitioning.
Sure. Sounds good.
So the component design may be high level I've covered. Load balancing and caching I have mentioned here. Uh, so replication and partition, I think we can talk about that. So probably I'll talk more about the partition. So partitioning, we can partition based on user ID or like so we'll end up doing a partition of user ID and a message hash
Mm-hmm.
using consistent hashing. So user ID mainly because of legal requirements. So sometimes some countries, let's say China, have these strict requirements that the user information of that particular country is saved in that country. So
Mm-hmm.
during the for certain countries, uh, you might have to store the user specific information there and make sure you have encryption between while chatting, and rest is as much as possible is there in that country. And for when it comes to messages, we can go on with different kinds of messaging algorithm. Like we can have a range based partitioning, we can have uh, a very simple user ID based partitioning even in for messages. But
Mm-hmm.
uh, once we are within a country, I think we can divide it into zones based on how interactive they are. And
Mm-hmm.
once that is done, I think it makes sense to have a consistent hashing kind of a partitioning where every message is sort of you know uh, in a hotspot. Let's say USA, everybody is talking a lot and people are chatting with all the states, everything is active, right? So it makes
Mm-hmm.
sense to have that the messages are divided. Every message is given a hash, and that hash is stored on different logical cores. And the yeah, in consistent hashing you store them in a round robin fashion in
Mm-hmm.
each logical core, and the logical core itself is randomly stored on different bare metal uh, servers. So that
Okay.
way the risk is distributed, and replication is also simultaneously done here. So for every hashing you create 3 replicas, and then the replicas themselves are randomly distributed across multiple data centers.
So what would be the initial number of partition in this case to handle the 1 million DAU and based on our your calculation?
Okay, number of shards. So let's see how much data storage we have. We have like 20 GB per day, right? So
Yeah.
we can have probably like, let's say 20 GB into 360 GB per day, and let's look at the 36 terabytes, which is like, let's say 100 terabytes. 100 terabytes. We can have maybe 10 shards each with 10 terabytes. Uh,
Okay, let me just take back my question. I don't want you to take the pain of the calculation. I don't care about the specific number. My main point is it better to start with a single partition and we receive more traffic, we go split the partition into multiple, or do you think it's better to start have a multiple partition at the beginning to handle this much traffic? What would be your deciding point between the two?
I would say reliability is still a major component of this application.
Mm-hmm.
So we should start with at least more than one. at least
Mm-hmm.
2 to 3, and then we can scale as the traffic increases.
Hmm. Okay, I see. That makes sense to me. Yeah.
Right. So yeah, replication and partitioning sort of goes hand in hand. So as you partition itself, you create replication and you put it under different tracks.
Hmm.
So I think that almost comes to the end of my design.
Mm-hmm.
I think I covered the major points we had at
Okay,
Replication.
let's come back to your system component. I have a few questions on there.
Sure.
So, yeah, if we receive more huge traffic, which component would be the bottleneck in the future, you think? And how would you resolve that?
I would say synchronization service, I think, is a big bottleneck.
Mm-hmm.
Because block service and metadata service, just writing to a cache and reading from them, is a solved problem industry wise, and it can be individually scaled. Like
Mm-hmm.
as you throw more boxes, it'll linearly scale its performance as well. So I would say synchronization service is definitely a bottleneck, and uh, even this can be handled with Kafka queues and distributed messaging services which are available.
Mm-hmm.
And if we can, you know, keep it well powered and well greased, in the sense we have as many nodes, it's running out on Kubernetes, on Docker, something like that, and it can handle partition tolerance when one pod goes down, another pod comes up. So if we can handle it, then I think even this can hold uh, that tension.
I see. Hmm. So another question is, as you know, one of the requirements is to store files as well, right? So in your system, I don't see any storage there where we want to store file into. Is it like a metadata or different storage that you're thinking? Or is it just a mist here?
uh, I think I ended up, so when I use block servers, I think we should divide this into message as well as this thing. So something similar for this thing as well, for files. So
Oh,
it's not the same data. It's not the same database.
uh-huh.
I just did not write one more database.
Okay.
So you can imagine the similar, triangular structure for file as well.
Hmm. I
So
see.
it'll have its own cache. It'll have its own database, and that will be HBase for file, and for message it will be, we can use Cassandra. I think Cassandra or even HBase will work.
Hmm. Okay. I see. Right. I think, yeah, let's just wrap up the interview and move on to the feedback session. What do you think? I think time is
Sure.
almost up for us. Okay, my time. So overall, I think you did pretty well. I didn't find any red flag on your demonstration during the session, which is good. But that being said, I have a few things to mention that you can improve on for your future interview, in my opinion.
Sure.
Overall, I think the crux of the systems interview, from my experience, is a few parts. Like first one, as an interviewer, I want to examine a candidate's technical background is solid or not, and the experience is real or not, right? And also technical knowledge check as well. So on that part, you did pretty well. I can see your technical background and knowledge is kind of solid, and you do know about the solution that you are suggesting, like Kafka or Cassandra or partitioning, which was good. But I think you can work on or improve the second part. I think your system should be convincing and suggesting or backing up by good knowledge and rationale. So I think your system is okay, but a few questions that I asked, I didn't feel that you are strongly backing up your suggestion with your own rationale. So in other words, your system design idea was not that strongly convincing to me.
Okay.
So Yeah, I mean, yeah, it's just again open-ended question. There's no absolute answer, but at least as an interviewee, you have to kind of try to convince your interviewer of your system design and your idea or suggestion during the interview, right?
Got it. Yes.
Yeah, so yeah, you can just prepare and improve that part for the future interview. Just over my impression,
Sure. So
and
can you
also, uh-huh.
emphasize which were the parts where you felt I had knowledge gap?
First of all, the asynchronous versus synchronous part flow. I didn't feel that you are well aware about like the main difference between asynchronous and synchronous. Maybe you are, but I think at least you didn't kind of convince me strongly.
Got it.
I my
Okay.
impression was like this candidate maybe yeah didn't know about the main difference or maybe didn't have the enough experience of the designing with the asynchronous component or synchronous component. Just my impression. I could be wrong, but
Mm.
again, this is the interview and this is my impression as an interviewer.
Understood. Okay.
Yeah, and also going back to the non-functional requirement. Here, I think this is where that you can impress your interviewer with good questions more. I think you did pretty good in terms of the giving a number like 1 million DAU image size and message. And I think there are a few more good questions that you can try, like the number of maximum group size, for example, and yeah, number of concurrency per second that which is system your system should handle. So you can think of more good questions on the non-functional requirement. I think. Does that make sense to you?
Yes. Yes.
All right. And the final thing which I wanna mention for you is 1 second. And also your system diagram didn't cover the file flow until I mentioned. So basically, you have to verify your system meets the given requirement, but I think that's kind of missing part here. And also, it's better for you to verify that this system kind of work on the given the traffic, the 1 million user in some way.
Okay.
I think this is pretty much it. Besides that, I didn't find any negative thing from what you did. And actually, there are good things that you did. I was impressed because I gave this same question to multiple candidates on this platform. I think on the beginning part, you did pretty good at narrowing down the ambiguous system question into specific topics, and you tried to set like expectation between you and I, which was very great. Because the system design can go anyway. I saw a lot of candidates just kind of waste of their time on some non-important topics. And always I try to give the feedback for that guy, but about the time management. But for you, your time management was pretty good by focusing on specific topic and ask me like what are the kind of main topics that you want to discuss as an interviewer, which was very great. I think you should do that. You should keep doing that for any of your future interviews.
Got it. Yeah. This was the feedback I got from my previous mock, which I incorporated in this mock.
Nice, nice improvement. Nice. Yeah, I think this is pretty much it that I have. Do you have any question or concern or things to discuss with me before I quit? By the way, after this, I'm gonna provide okay written feedback with more details, as
Yeah,
you
that will be
know.
great. Yeah. Thank
Yeah.
you so much.
Right.
And
Right. Uh-huh.
one last question. You said that somehow I have to convince you that the system design can handle 1 million DAU.
Yeah.
So how do I do that? Because initially we discussed we will not cover telemetry. Telemetry is usually analytics is one way, usually how we can convince.
Hmm.
So how can I do it without telemetry?
Oh, maybe telemetry. I interpreted it in different way. I think in that case, maybe you should ask me before finishing that, just to make sure that we agreed not to cover telemetry at all. Or maybe still you might want to verify your system cover this much traffic with me as a kind of some interview skill, I think.
Got it. Okay.
Yeah. Right. Then goodbye and have a good night.
Yeah, thank you so much. This was very helpful. Yeah, good night. Have a nice day.
I'm happy to be helpful to you. Bye bye.
See you.